Hello everyone. In this question, we are asked to evaluate the integral of x ln sin x dx as x goes from 0 to pi. Okay, so if we write this integral as I, so let I equal to integral of 0 to pi x ln sin x dx. Okay, so we can substitute this x with pi minus x, right, throughout the integral. So we have the integral I as 0 to pi. Instead of x we are using pi minus x. Ln sine of pi minus x will again become sin x, right? It will be in the second quadrant, so this again becomes ln sin x dx. Okay, so we have I equal to, if we split this into two integrals, this first integral becomes pi integral 0 to pi ln sin x dx, right? And the other integral becomes integration of x ln sin x dx 0 to pi. So this again becomes the original integral, right? So this again becomes I. So from here we have 2I equal to integral 0 to pi ln sin x dx times pi. So we get I equal to pi by 2 0 to pi ln sin x dx, right? Now instead of this being from 0 to pi, if I change this upper limit from 0 to pi upon 2 ln sin x dx, so this integral I have half the limit, right? So this will become 2 times in order to maintain this 0 to pi. Okay, since sin x is symmetric from 0 to pi, if I change the upper limit from 0 to pi by 2 instead of 0 to pi, this entire integral will become 2 times. Okay, this is the property, that is, the property is, if we have 0 to a fx dx, this will become 2 times 0 to a over 2 fx dx, and this is valid if f of a minus x is equal to f of x, right? So in this case our a is pi, right? So and fx is ln sin x. So if you use this pi minus x here, you will get this original fx, right? So this is what I have used here. So we have I now equal to pi by 2 times 2, so this 2 will cancel each other, so we are left with pi times integral of 0 to pi over 2 ln sin x dx. Okay, so I can write it as, let I equal to pi times, say this is integral j. Okay, this integral. So in order to find I, now we also need to find this other integral j. Okay, so we have j equal to 0 to pi over 2. Let's say this is equation 1. Okay, this is I and the second one is j. So this is ln of sin x dx. Okay, so again I can, instead of x I can write pi by 2 minus x throughout the integral. Okay, so this becomes 0 to pi by 2 ln sin of pi by 2 minus x dx. So this becomes 0 to pi by 2 ln sin of pi by 2 minus x is nothing but ln cos x. Okay, so we have j equal to ln sin x dx and also ln cos x dx. So if I add those two, this one and this one, we have 2j equal to integration 0 to pi by 2 ln of sin x plus ln of cos x dx, right? So this becomes 0 to pi over 2 ln of this is ln a plus ln b, so this will become ln a b, right? So this becomes ln sin x cos x product dx. Okay, so this can be further simplified to 0 to pi over 2. This can be written as ln sine of 2x by 2 dx, right? I have multiplied a 2 inside this bracket and divided by a 2, so this becomes 2 sin x cos x, which is sin 2x, and upon 2. Okay, so if we separate these two integrals here, this is ln a by b, so this becomes ln a minus ln b, so this becomes 0 to pi over 2 ln of sin 2x dx, and the other one will be just ln 2 dx. Okay, so ln 2 is a constant and integration of dx is just x with the limit, so the limit is from pi by 2 minus 0. Okay, so this becomes ln 2 times pi by 2. Okay, so here if we use a substitution, say u is equal to 2x, so we have dx will be equal to u by 2 will be x, right? So we have dx equal to du by 2, and also the limits will change from 0 to pi over 2. This will change to, when x is 0, u will also become 0, and when x is pi by 2, this is 2 times pi by 2, so this will become pi. Okay, so we have 2j equal to 0 to pi ln, this will become sin u times dx will become du by 2, right? So this entire thing is in the graph. Okay, and we are left with ln 2 times pi by 2. So again, if I divide this entire right hand side by 2, we get j equal to half times integral 0 to pi, and here for a definite integral, this this sin u du can be replaced with the other dummy variable sin x dx. Okay, so this will become ln sin x times dx by 2 minus, this will become ln 2 times, if this 2 is divided here, this will become ln 2 times pi upon 4. Okay, so we see that if I take this 2 outside, this will become, j will become 1 by 4 times 0 to pi ln sin x dx, and this becomes pi by 4 ln 2. So our original j was from 0 to pi over 2. Okay, and here it is 0 to pi, so this will be just double 2 times, right? So j, this will become 1 by 4 times 2 times 0 to pi over 2 ln sin x dx minus pi by 4 ln 2, right? So now we can substitute this j here, right? This was our original j, 0 to pi over 2 ln sin x dx, right? And this is what we have got, so this just becomes j upon 2 minus pi by 4 ln 2. So we have, if this j by 2 goes to the left hand side, this becomes j by 2 is equal to minus pi by 4 ln 2. So from here we get j equal to minus pi by 2 ln 2. So if I take this minus sign to the power of 2, this will become pi by 2 ln half. Okay, so now I can substitute this value of j in this original integral in 1. Okay, so from 1, I was equal to pi j, right? Pi times j, so I have to just multiply this integral with the pi, so this just becomes pi square by 2 ln half. Okay, and this is the required value. Okay, this is the required answer, that is 0 to pi integral of x ln sin x dx is equal to pi square by 2 times ln half. Okay, this is the required answer. Okay, so this was a bit lengthy. You need this two integrals. You need to compute these two integrals separately. Okay, in order to get this x ln sin x, you also need to find this integral ln sin x. Okay, so once you do that, the rest is a bit computation, but the rest is not that difficult. Okay, the substitutions were not that difficult. You can easily do these substitutions. Okay, so this is the required answer. This was a bit lengthy. If there are any doubts, you can highlight in the comments, and if there are any shorter methods known to you, you can also highlight in the comments. Okay, I will pin that comment. So this is it. Thank you for watching.